In this video, we're going to talk about integer exponents. We're going to give a definition, look at some properties, and then get some practice on how exponents interact with each other. So we have what's called exponential form, which means we're going to write an expression using an exponent. And the reason why we would need an exponent is because we have some kind of repeated multiplication. So I'm multiplying by the same number or the same variable, multiplying it by itself any number of times, and that's when I use an exponent. So we read it as the nth power of a, or you could say a to the n. And so when that occurs, we're multiplying a times a over and over again n number of times. So each of these parts has a name. I don't usually test you on the names, but it is good to be able to talk about things and have a name for some things. So the a is usually called the base, and the n is called the exponent. Okay, so now that we kind of have the basic setup, let's look at what we can do with exponents. All of these, of course, are in your book. There's 7 properties that we're going to look at today, so we'll just do them one at a time, and I have a couple examples for each. All right, the first one's called the product rule. So product indicates multiplying, so when I'm multiplying two expressions that have an exponent, and I have the same base, which is kind of important, then when I'm multiplying, I'm going to add the exponents. This is really just like having a stack of A's and then a second stack of A's. And I'm just going to combine them into one stack. And the exponent is going to tell me how many I have in total. Since I'm totaling them up, I'm going to add in that case. Right, so I have 2y's in this stack, 4y's in this stack. If I put them all together in one stack, I'm going to have 6 of them, right? And I add the exponents to do that. How about this example? Feel free to pause the video if you want and take a try at it on your own. When we do something like this, we would multiply the numbers and then we would multiply the variables and kind of keep them separate. So 6 times 9 would be 54. And then multiply that by 2, should give us 108. And then all of these are z's, so we can combine them together by using this property. I have 5, I have 3 more would make 8, plus 2 more would make 10 z's all together. Okay, and that's called the product rule. The second property is called the power to a power rule. So I have sort of layered some exponents. So I have a to the m raised to another exponent n. So this is, again, like having multiple stacks of a to the m. And so I could add m plus m plus m plus m, but usually instead of adding over and over again, I multiply to make it shorter. So that's why I'm still counting them up. But I'm using multiplication because I have them in equal groups. So for example, 5 to the 3rd squared, right? I'll write it out over here just so you can kind of see. That would be the same as 5 to the 3rd times 5 to the 3rd. The 2, or the square here, just means I have 2 copies. So these two piggyback off each other, right? Now I would add them together, 3 plus 3. Or I could just do 3 times 2. I have 2 3's. That's the idea. 5 to the 6th. And because I have a 5 there, I could then work out what that was equal to if I wanted to. I'm not going to do that right now. Same thing here. I have 6 stacks of 4 x's. Right? So if I added them all up, 4 times 6 would give me 24 x's in total. The third property is called the product to a power rule. So if I have two things that are multiplied, like a times b, and I want to raise them to an exponent, in a sense, I can distribute that exponent to each part. I can't do that for addition or subtraction, but I can do it for multiplication, and as you'll see in a minute, division as well. Okay? So let's say we have 3x squared cubed. This power of 3 on the outside is going to apply to both. You could write it in multiple steps if that was something that was easier for you. So I'm going to cube the 3, and I'm going to cube the x squared. It's really easy to remember the variable, but sometimes we forget to do the number or the coefficient as well. So 3 cubed, and I could have written this on the outside. It doesn't matter. 3 times 3 times 3 would give me 27. And then I'd use my last rule and multiply here to get x to the 6th. Okay, just like we had the product rule in number 1, sort of its pair would be, its opposite maybe would be the quotient rule. So now if I'm dividing a to the m divided by a to the n, I can subtract the exponents, right? So this subtraction kind of pairs up with the idea of canceling. So let me show you what I mean. If we have a to the 5th, which would be like having 5 a's in the numerator, 1, 2, 3, 4, 5, divided by a to the 3rd, okay, each pair, I guess, 1 in the top and 1 in the bottom, a divided by a is 1, so we can cancel them 1 for 1 from top to bottom. And then what's going to be remaining are the 2 in the top. So I had 5, but I canceled out 3 of them, and my result was a squared. Right? So I can subtract, or I can think about canceling. Either one works here. Okay, so try one more. It's the same idea with the x's and the y's. Let's start with the canceling idea, right? If I have 2 x's on top and 1 x on the bottom, I'm going to cancel out 1 x, and that's going to leave me with 1 x on the top. If I have 6 y's on the top and 8 y's on the bottom, I could write them out. It would be a bit tedious, but I could cancel out 6 of them on the top, cancel out 6 of them on the bottom. I have more y's on the bottom, so it'd end up having 2 left on the bottom. Okay, if you did the subtraction method, let me write that out for you, okay, down here. You could also subtract, so x to the 2 minus 1 power, and y to the 6 minus 8 power. And that's going to give you x to the 1, or just x, and y to the negative 2. Okay, in just a minute, we're going to talk about negative exponents. That's its separate property. So this negative 2 is what's going to put that y down into the bottom of a fraction. So this and this would be the same. And you'll see that in just a minute. Number 5 is the quotient to a power rule. So if I have some a divided by b, a fraction of some kind, and I want to raise it to an exponent, just like in number 3, where I said I could sort of almost like distributing the exponent, I can do it for division as well. So it goes to both the top and the bottom. This is the one I sometimes forget, to be honest. Let's say we had negative 2 divided by t squared, and I wanted to raise that to the 5th power. It just means I have 5 copies of this fraction multiplied together. So on the top, I'm going to have 5 negative 2's multiplied together. On the bottom, I'm going to have 5 copies of t squared multiplied together. Okay, let's do the bottom first. So power raised to a power, that's where I multiply. This would be t to the 10th. You could plug this into your calculator. It's 5 negative numbers multiplied together, so it's definitely going to be negative. 2 times 2 times 2 times 2 should be 32. Number 6 is called the zero exponent rule. So if I raise any base to an exponent of 0, okay, any base except for 0 itself, because the 0 to the 0 is undefined. Okay, but any other number raised to the 0 is always going to give me 1. The explanation I usually give, right, is sort of like, this is almost like the identity. I don't have any copies of the base multiplied here. So I just have the identity 1. That's kind of the reasoning behind it, right? If I had 1, let's not use a variable, let's use 2. If I had 2 to the first, that would mean I have 1, 2 multiplied by itself. If I had 2 squared, that would mean I have 2 2's, 2 times 2, right? 2 to the 0 means I don't have any 2's that I'm multiplying with. I just have that multiplicative identity. Okay, so it kind of keeps this pattern going. So it can be a positive number like 3. It could be a negative number like -4. Okay, there. I always make a little side note here. I don't think it's not written in here, so let me just make a side note. The parentheses are important. I totally didn't spell that right. Parentheses, there we go, are important. So if I were to have, I'll just put it right here. If I did not have parentheses, okay, when I do have parentheses, the exponent applies to both the 4 and the negative. When I don't have parentheses, the exponent only applies to what it's directly next to. So I have 4 to the 0, which is 1, but then I have this negative out front. This is the only case, right, if I don't have the parentheses, when I would get something different than 1. Everything else was going to be that 1 according to this rule. Okay, last property is the property that deals with the negative exponent. So a negative exponent is different than a negative number. It indicates a reciprocal or a flipped over fraction, right? It's very much related to the keep, change, flip idea. So I'm really flipping because I'm dividing by something. And so the way it's going to appear is that if I have a negative exponent, this is sort of like in the top of the fraction, it's going to move across the fraction bar into the bottom. Okay, if it were in the bottom and it were a negative exponent, it would move across the fraction bar up to the top. And this can appear in a lot of different ways, so there's usually 3 separate ways to write this, right? And these are listed in your book. So here's kind of what we were just saying, right? So if I have one in the top of the fraction, then that's negative exponent is going to allow it to move down into the bottom. And again, it's related to that keep, change, flip. So when I do the division, I multiply by the reciprocal and it moves it down into the bottom. And the negative exponent in the bottom is going to cause it to move up to the top. If I have it written as a whole fraction raised to an exponent, that negative is just going to flip, right? So the negative exponent applied to the a would move it down to the bottom, and the negative exponent out here applied to the b would move it up to the top. So let's just try that out. Okay, so if I have -3 raised to the -1 power, this is a lot like this first one, right? The fact that this 3 is negative has nothing to do with the negative exponent. They're not related at all. So what happens is this whole thing, if you want to think of it in the top right now, it's going to move down into the bottom. You could think of it like that first if you want. If there's nothing left in the numerator, there's a 1 there to hold the place. That's that identity again. Okay, anything to the first power is just itself. So really this is like -1/3. And keep in mind, it doesn't really matter where I write this negative, right? I kept it in the bottom just to kind of be clear and really obvious about it, but I could have written it out front, I could have written it in the top. As long as I just have the 1 negative, I can put it in any of those 3 places, just not more than 1 place at a time. Okay, here's my 1/2 raised to the -3 power. This is sort of like this one, right? So the negative exponent is going to flip this fraction. So it's going to become 2/1 to the power of 3. But 2/1 is really just 2 to the power of 3. 2 times 2 times 2 will give me 8. Okay, and then if I have a negative exponent in the denominator, it's going to move what I have up to the numerator, right? This really is like 1 divided by 4 to the -2, right? It's like a complex fraction. So it's going to flip it up to the top. And since there's nothing left in the bottom now, I have a 1 there. 4 squared over 1 is just the same as 4 squared. 4 times 4 is 16. Okay. Here's a couple more examples, just to make sure you got it. So these first 2 are kind of related to that parentheses idea, right? So whether I have parentheses or I don't, if I don't have parentheses, the -1 only applies to what it's directly next to, which in this case would be the x. So right now, everything is in the numerator. The x has the negative exponent, so it will be the one that moves down to the bottom. But the 2 does not, so it will stay in the numerator. However, if we have parentheses, then the -1 applies to everything right here, which means that all of it will move down into the denominator. And once it moves, the exponent becomes positive or changes sign. There's nothing left in the numerator, so there's a 1 there. Right? So we could write these kind of in a more comfortable way, like 2/x or 1/2x. Okay, how about a couple more like that? So what is going to move in this fraction? I have the parentheses, so everything moves. Right? This whole thing moves to the top. There's nothing left in the bottom, so there's a 1 there. This time we can kind of distribute this square. So this would be the same as 3 squared and x squared, or 9x squared. Okay, what will move in this example? Since we do not have parentheses, only the x will move. The 3 will stay. The x would move to the top. Technically, when I move this x to the top, it's multiplied by this 1. So if this were any other number, like a 4, let's say, then I would keep the 4 up there, and it would be 4x squared. Okay, there are definitely more complicated examples in your book, so I want to take a look at a couple of those. Here is the first one. All right, we probably could have worked our way up to this maybe a little more gradually, but I didn't do that. So I can fill in with other examples later if you need them. But we want to simplify this as much as we can. And we want to use what we know, all those properties of exponents to combine our y's together, combine our z's together, and do some of that. There are a whole lot of different options you have, right, as far as what order you do the steps in. So it's usually confusing if I show you 10 different ways to do a problem. So I'm going to choose one way and kind of roll with it. But if you saw this problem and you decided to take a different route, that's okay. There are a lot of ways to get to the end on these. And so we may not all work them out the same as far as what order we do our steps in, but we should still all get the same final answer if we do them correctly. Okay, so I don't really see a huge benefit of one method over the other. If I did, I would definitely point that one out to you. Maybe you want to take care of these negative exponents inside the parentheses first. Today that seems good to me. I don't know. So I'm going to do that. So I'm going to keep this -1 on the outside for right now. And I'm going to deal with it in a minute. Okay, so inside these parentheses, anything with a negative exponent is going to move to the bottom, right? Because right now these are on the top. So the y to the -6 is going to move to the bottom as y to the 6th. And everything else is going to stay in the numerator. Likewise over here, the z to the -2nd is going to move to the bottom. And the 2y squared is going to stay in the numerator. Okay, before we multiply these together, we really have to take care of this exponent on the outside. Since it's a negative exponent applied to a fraction, it's going to flip this whole fraction over. Okay, now we could leave the parentheses. I'm going to go ahead and take them off since we're about to combine everything together. All right, now we're multiplying fractions. So we're going to multiply the tops together. Y to the 6th times y squared should give us y to the 8th. And z squared times z squared should give us z to the 4th. Because these are different variables, we can't really simplify this part any further. 2 can't be divided by 3, so we're done. Okay, now just as a side note, right, like I said, you can do these in a lot of different ways. So if you decided to do this outside exponent first, everything in the parentheses, as is, no changing of signs, would go all down to the bottom. And then you could combine fractions and then move things around. So you really do have lots of options. Okay, so here's another example. Same thing's true. We still have all of our options open. So I don't know what you feel like would be good to do first. We could simplify on the inside first, or we could flip it first. For some reason today, I feel like flipping it first. So how about we try that? If I flip it, and I do this exponent on the outside, this is the exponent that's going to become positive. So I don't need to change anything on the inside yet. So 125xy is exactly what comes to the top. And all of this stuff in the numerator, including this -3, stays the same, and it all goes down to the bottom. Okay, so let me just copy that. But 5 squared, I know that's 25. Okay, now we can simplify our numbers, we can simplify our x's, and we can simplify our y's. So first of all, 125 divided by 25, that should give us 5. Okay, now as far as combining the x's and the y's, you have two options. You can, let's say just for the x's at the moment, right? You could subtract the exponents, or you could think about canceling. There's 1x in the top, 3 x's in the bottom. Let me write this off to the side. We did this earlier. So in my head, I'm thinking like this. So I've canceled 1x out, which means I have 2 x's left over in the bottom. Okay, that's one option. Or you could think of it like subtraction. X to the 1 minus 3 power would be x to the -2. When I do this subtraction, this x to the -2 is in the top, and then I can move it down to the bottom, right? So there's kind of two rationales you could take to get to this point. Either one is fine. It's really just a matter of personal preference. Okay, likewise for the y's, you could do the same thing. I like to move the y to the -3 to the top. You could, and I'll write it off to the side, subtract the exponents if you like that better. It would be, this is y to the first, so you'd be subtracting -3. Oops. 1 minus -3 is like 1 plus 3, which would give you y to the 4th. And again, if you do subtract the exponents, your result is in the numerator. Okay. Whichever route you take to think it through, we've mentioned several here. We should still get the same result either way. All right. There's a few more topics tacked on at the end of this section that go along with exponents, so I'll just squeeze them in real quick. One of them is called scientific notation. Usually you've already seen this before, but I'll just kind of give you a little bit of a refresher. This is used to write very small or very large numbers. Here's the format that we use. We have a number in the front that's a decimal. It has 1 digit in front of the decimal. So it's bigger than 1, but not 2 digits in front of the decimal, so smaller than 10. You can go up to 9.99999. Okay, and then we're going to multiply by a power of 10. That way, we don't have to write, say, 1,000,000 or 1,000,000,000 with all those zeros. We can kind of shortcut it by telling how many zeros we have as an exponent, and that's why this ties in with exponents. We know we're going to have a number that's bigger than 1 if we have a positive exponent on the 10. That's sort of like multiplying by 10 many times. We know we're going to have a number smaller than 1 if we have a negative exponent on the 10. Because think of that putting it into the bottom of a fraction. That's like dividing by 10 over and over again. Okay, so let's try it out. So 250,000, right? The C, remember we said, is going to move the decimal. Currently it's right here. We're going to put the decimal so that there's 1 digit in front, which would kind of be between the 2 and the 5. But we're not changing the number at all, right? So if the decimal were right here, we would need to move it back to where it was by multiplying by 10. 1, 2, 3, 4, 5 times. Notice I moved to the right. If I have a positive exponent on the 10, I'm moving the decimal to the right. Okay, opposite of that would be something like this, 0.189. Again, for that C number, we want to move the decimal so that there's 1 digit in front. So that would be 1.89. But we don't want to change the number at all, so to move it backwards, it's supposed to be, we need to move to the left 1 place. So that's, to move it to the left, we have to divide by 10, which means we need a negative exponent. So the negative exponent is going to move the decimal to the left. Okay, same thing here. And now I'm going the other way, right? So I'm multiplying by 10 to the third. So it's a positive exponent, so I'm going to be moving the decimal to the right 3 places. That would be negative 1, 2, 3, right? 7,850. And for the last one, we are negative 5 as our exponents. We're going to move it to the left. 1, 2, 3, 4, 5. So that's going to give us 4 zeros. 5, 8, 7, 6. Okay, the last thing in this section deals with order of operations. This is another one of those ideas that's, it's a review, but it's something we use all the time and we really don't talk about it that much. This is the please, I have please here, but please excuse my dear Aunt Sally, right? So parentheses first, then exponents or powers, then multiplying and dividing together, and adding and subtracting together. So let's just work this out. For nested parentheses, that's this, right? So if I have parentheses inside of parentheses inside of parentheses, I need to work from the inside out. So a really good first thing to do would be this part right here. Because the negative 5 squared and the square root is 36 don't really mess with this middle section, we can go ahead and do that at the same time also, just to save ourselves some time. Negative 5 squared, that would be 25. The 6 plus 3 here is going to give us 9. And then we're going to do the parentheses next, so 4 minus 9 would be negative 5. And then we can do the multiplying. So negative 8 times negative 5 would make this 25 plus 40 minus 6. Okay, I'm going to draw a line here so it's not too crowded. So if I add that all up, right, 25 plus 40 would be 65, minus 6 would be 59. Okay, it works the same way if there's a fraction. We would do the numerator and the denominator separately. So 3 minus 7 would be a good first step. And you could definitely do some of these smaller steps in your head. I did my parentheses first, I did my exponent, right? And then I'm going to do my multiplying. So this would be negative 28 plus 1 over negative 8 minus 1. So that's negative 27 over negative 9. Okay, and I have to simplify my fraction last. So negative 27 divided by negative 9 would be 3. All right. I hope that you'll take a few minutes to practice with exponents and do some examples on your own. And I think this is probably one of the biggest sections in our first test, so it would be worth it to kind of spend some time on the material in this video. So good luck, and we'll see you in the next time.